right, this is lesson 6.1, and I'm going to go over a couple more examples and help you get started on your assignment. So this says, for each scatter plot, estimate the value of the correlation coefficient R. Tell whether it would be close to -1, close to -0.5, close to 0, close to 0.5, or close to 1. All right, so all we're doing is predicting what this is close to. All right, so you can see this is a positive correlation, so it's going to be either 0.5 or 1. This looks like a very strong. It's pretty closely related to this line. So this example would be close to 1. So R would be close to 1. Not exactly 1 because the points are not exactly on that line, but it would be something like 0.93 or 0.96 or something like that. Okay, so it'd be close to 1. All right, so this one, it is going downhill, so it's negative. So it's going to be -1 or -0.5. And you can see that these are further away from the line. Some of these are not as close to the line. So this one's probably going to be closer to -0.5. Doesn't mean it's going to be exactly -0.5, but it's got several points here that are not as close to that line. So this one would be close to -0.5. So all you have to do is choose what R would be close to. All right, for this one, it says the table contains data for the total amount of money in dollars collected at a movie theater concession stand and the total number of movie tickets sold each day for 5 days. All right, so movie tickets sold on the first day, it was 23, then 42, 60, 85, and 124 tickets sold. And you can see the concession stand sales here. So it says make a scatter plot and describe any correlation. All right, so again, I showed you in one of the tasks that you could do this using your calculator. So I'm going to walk you through this so that you can do this as well. So when you turn your calculator on, if you go to Stat, the very first thing says Edit, and that's what we want to do. We want to edit because we want to enter these points in our table. So we're going to hit Enter. And if you have points here, you need to go second plus 4. Second plus 4 will clear out any numbers in your table. But if your table is empty, then you simply enter your X's in L1, so 23, 42, 60, 85, and 124. So it doesn't matter if our table goes sideways or if it goes up and down. We do know that movie tickets sold, this is our independent variable. So however many tickets sold, that will determine how much concession stands are sold. So then arrow over and our Y's or our concession stand sales goes in L2. So 155, 189, 341, 420, and 565. All right, now it's always a good idea to look back up here, 23, 42, 60, 85, 124, and just kind of make sure, double check that you entered these numbers correctly, because if you don't enter this correctly, your calculator cannot give you good information. It can't help you, okay? All right, so now we're going to go to Stat Plot, make sure our Stat Plot is on. Mine is on from the last example. So now we can go to Graph. Now it's showing 2 points, and we know that we should have 5 points here. So again, we need to go to Window. We have X's from 23 to 124. So we're going to go from -1 up to past 124. So let's go up to, let's say 125. And then a scale of, let's do a scale of 10 this time. And then our Y values go from 155 to 565. So we're going to have to go from -1 because you have to have a negative number there. But we need to go past 565. So let's do 575. You can choose 600. You can put whatever you want there. Okay? All right, so let's change our scale since we're going all the way up close to 600. Let's go ahead and change that to 600. Let's change this, our scale, to 25. Let's go by a scale of 25. All right, so this gives us our data points here, and you can see that that looks like, it says make a scatter plot and describe a correlation. To me, this looks like a strong positive correlation. All right, do you think there's any causation? Explain. All right, remember causation, does one thing cause the other to happen? Like when the kid was growing, did one thing cause the other? Did the height of the kid come from the age of the child? And that was a causation. So, does the number of concession stand sales depend on the number of tickets sold? And I would say yes. The more tickets you sell, the more people are at the movies, which means naturally there are going to be more concession stand sales. So yes, there is a causation where if there's more movie tickets sold, there's more people to buy concessions. All right, it says fit a line of data in your scatter plot and write an equation for it. All right, so there's a couple different ways to do this. First, take a couple of these points and find your slope. So let's do that. Actually, just because of time, I'm going to show you how to do this on your calculator. You should know how to find your slope. Y2 minus y1 over x2 minus x1. You can use any points here to find your slope, and then use one of those points and the slope to write an equation. You can also have your calculator do this. If you go back to stat, you've already got your points in there, and you can go over to calculate here, and we want a linear regression. We want a linear equation. So if I hit 4, remember linear is a line. So we're going to do L1 and L2. That's where we entered our points. And we're just going to enter through all of this, and the calculator will write an equation for you. All right, so y equals ax plus b. A is your slope in this case. A is 4.23 approximately. And your y-intercept is your b, 51.29 approximately. All right, and r is your correlation. So this has a correlation of 0.98, which is very close to 1, so it is a strong positive correlation. So when it says fit a line, okay, I can take this line and I can go to y equals, and then I can do the same thing again, calculate, and then I can do, let's see, VARS, number 5, statistics, go over to equation. I needed to do that in my y equals. Let's do that again. Go to y equals, go to 5, equation, enter, and then graph. So what that does is it graphs the equation that it just found over top of those points so you can see your line of best fit. Okay, and it already gave you your equation and your R. So what do the slope and the y-intercept of the line of fit represent in this situation? Well, the slope represents the increase in concession stand sales per movie tickets sold. And the y-intercept represents the concession stand sales when no movie tickets are sold. Okay? All right, so it says use the line of fit to predict the concession stand sales when 75 movies or 75 movie tickets are sold. All right, so we're going to take our equation. Let's write down our equation first. I'm going to calculate this one more time just because I want to be able to write it down here and use it. All right, so I've got y equals 4.23. And then plus 51.29. All right, so we take that and we're going to say we want to know if 75 movie tickets are sold. So we know that we entered this for X and this for Y. So for X, all we have to do is enter 75 tickets. So we're going to put 4.23 times 75 tickets plus 51.29. And I can use my calculator to do that. So I'm going to do 4.23 times 75 tickets plus $51.29. So we're going to have about $368.54. So $368.54. All right, so concession stand sales would be about 75 would go in here somewhere, and $368.54. All right, so because 75 fits inside the domain here, that means this is interpolation. Okay, hopefully you've reviewed these definitions. All right, so it says use your line of best fit to predict a concession stand when there are 200 movie tickets. So we're going to say Y equals, still have the same equation, 4.23 times 200 plus 51.29. All right, so let's use this equation to figure this out. So we're going to have 4.23 times 200 plus 51.29. 897.29. 897.29. All right, so this says when they sell 200 tickets, 200 tickets is going to be out here somewhere, $897.29. All right, so when 200 movie tickets are sold, plug in 200 for X, then the concession stand sales will be $897.29. Okay, so because the domain 200 is outside the domain here, this is considered extrapolation. All right, so that's how you would use your calculator to find an equation, to see the correlation of a problem, and to figure out and how to make predictions of something within that equation. All right, that is all for lesson 6.1. If you have any questions, please let me know.